Recording. Welcome, everybody. Tonight is the 1st of November in Dallas. You're watching, or you're at Dallas Personal Robotics Group Robot Builders Night Virtual. We'll do what we normally do and go around the table for show and tell and questions and the like, Stump the Club. But just as a reminder, this is, if you're watching on YouTube, you're welcome to join. We generally meet each Tuesday night for free. Every second Saturday of the month, we have something in person, generally speaking, or a group meeting anyhow, a larger meeting with a presentation. So you can learn more about DPRG at this link and follow up with the latest members, meeting posts and such. In terms of other housekeeping, no changes on this stuff on the left. But the big thing coming up just a week and a half now is our annual outdoor robot competition, Robo Columbus. So you can find details at that link, which we'll post into the chat for this Google Meet. We have a handful of other ideas that have just been percolating around. But if there's no other items people want to throw into the list.
You could take that top one off the list. I don't think that's going to happen.
Okay, that fell apart. Wasn't sure. All right. Okay. And I think we actually did this one too, the Git, didn't we? Doug, you did a really nice presentation earlier. So, okay. Anyhow, any other ideas people want to throw up while we're on this slide? Okay, with that, I will stop sharing my screen. And we have in queue, roughly in this order, Ray, John, Michael, Doug, Todd, and John K., and then open mic. So with that, I think, Ray, you're up.
Okay. Enter screen. Share.
Okay, I have on a proto board a Adafruit Cutie Pie. This is the SparkFun BL53L5CX, and it has actually 64, I'm set it for 64 measurements. The area on the top of the screen is actually on the bottom of the sensor. And then as the bars go up, it's individual measurements increasing in vertical height. So right now I'm shining it against
Or pointing it.
the wall of the soccer course and then a wall further up. So, that seems to be pretty good. It's the lower part here is hitting the wall, or the wall of the soccer court. And then this is increasing, as it goes up. If I tilt this a little.
Yeah, or make it askew with the wall.
I have a peak now that indicates that, it's not parallel with the wall or parallel with the soccer court's wall. And if I square it off a little bit more, they'll square off as well. Right there. I also wanted to see how it would do against the soccer goal to see if it could find it. And it looks like it can. It's not certain that all of these results are what I expect. It shows a gap in the first one where it's short distances and then very long distance. And I think the long distance is as it goes from left to right, it's actually showing the gap there. So that could be useful. This is updating at a 1 hertz rate, not very fast, but it's doing 64 measurement in that 1 hertz rate. So So it's kind of interesting. Anyway, just wanted to show that.
Anyway, what I didn't say in there is that there's 8 individual bars here, and in each bar, I'm not certain which way it's measuring. I didn't try to figure that out. It's either right to left or left to right, and there's 8. It's an 8x8 sensor array, and so you get 8 horizontal measurements, and then 8 groups of those horizontal measurements, and for a total of 64. You can also set it in 4x4 mode, but I wanted to see, how much detail it could pick out, and it actually seems to do pretty good. So I was kind of
Ray, is
impressed.
that time of flight?
Yeah, it's the it's SparkFun's. Let's see, it's the VL53L5CX, or SEN-18642 from, if you put that number in SparkFun's website or do a search on it. But so each of this isn't the best shot of this. They're all kind of blurred together because of the brightness. But in each bar, there's 8 measurements, either left to right or right to left. So as the bar, as you progress up the bars, you're going left to right or right to left 8 times. And that's where, where I showed it being a little bit askew or not parallel with the soccer court wall or the wall behind it, that they actually had a peak on them to one side or the other, and that would be the shorter side, the longer side, because distance is increasing the further you go up in this direction up here. This is 0, and this is increasing direction up to 400 centimeters is the max it can do. But that's like perfect conditions, the right ambient lighting, a really reflective surface. But for the 10-foot soccer goal, that's the biggest distance, and that's a little over 3 meters, I think. No, under 3 meters, 2.5 meters or so. 6, 7, 8, 9. A little over 2.5 meters. Anyway, so I thought it was kind of interesting. It's kind of a not mechanically scanned, kind of like a 2D LiDAR.
So Ray, quick
Yeah.
question. What we see on the screen right now,
Yep.
the front part or the lower part, one that's
Yeah,
closest
down
to
here.
the sensor, that's the 8-inch wall
Yes.
of the court. And
Yeah.
then the other one is the distance of the wall behind the court.
Right. And it
Okay.
increases because the further up the sensor, scans its elements, it's further away. So these
You
bars
mean
are
because it's
increasing.
tilted, because it's slightly tilted backwards, and that's why you're seeing
Yes.
it's further and further as you go up the scale.
Yeah, the sensor here is not perfectly vertical. It's just stuck in the
Yeah.
slot here in the.
Yeah, so that's what gives you the slope on the second part.
Yeah.
Well,
And it should
Some
slow
of it's
it.
probably going to be parallax, right? Think of your field of view, right? As your field of view expands, it's going to be a greater distance to the edge.
Yes. But I think primarily it is because the sensor is tilted back a little bit. And this should also show a slight increase, but I don't think you can see it, but you can definitely see it here where it's, reflecting off the wall in behind the soccer wall.
And what did it, can you kind of like go back to where you had it looking at the goal?
Sure.
I don't know, that might be tricky.
Okay, where is it?
So, by the way, there's a GIF on the SparkFun page that actually shows kind of like a 3D image
Yeah, you can use processing for it.
What
Okay,
is
so let me see. So,
Yeah, and each of these, this is kind of whited out, but there are eight individual groupings of
gotcha.
distance measurements. And so this is, zero distance, and this is the max. And
All right.
I think I've scaled it. I think for like 3 meters or so
Okay.
um,
And
to the
since
max.
since this distance, because of where you had it originally and you just turned it 90 degrees, is much further to the walls than it is originally. So that's why the wall bars are higher. But I'm not quite, and the ones that are really high, that's the ones
here.
that's the goal.
Um,
No,
that
no,
I think,
otherwise, no. You see, you got black. So black
yeah,
means that it doesn't see it.
right.
So,
Well,
so
it looks like it is making a measurement here. There's no bars that go. Well, it'd be
no, no.
kind of
What I
hard to
meant,
see it.
yeah, but what I meant was that area where you are right there. I think is sections of the wall somewhere.
Yeah, I think it's above the wall, above the soccer goal wall.
You think so?
Yeah, and this is actually below it. And I think this gap and this one and possibly this gap, or where it's showing a shorter distance and then a much longer distance. The
Mm-hmm.
longer distance is actually through the gap in the goal.
Yeah, I would have expected that to be wider, though. I guess that's what I'm a little
Oh,
surprised
yeah.
at how narrow it is.
I kind of had it pointing at, let's see if I actually show it here. I thought I did. Yeah, okay, maybe I didn't. Thought I showed the goal. Yeah. Okay, so I don't follow a board up, but I think I'm like on this board pointing at it.
Okay.
So it should show, as it scans across, these should be the shorter distances and these should be the longer distances over here. And it's a little clear. But yeah, I think where it's showing the gap and so it may actually scan across from, well, nope, that looks like long distance and then a short distance. I'd have to look at the readings, to try to figure it out to see if it
Uh,
is actually showing
how hard
the
was
gap.
it to get? Was it to get here, Ray?
Oh,
Was
as
it
far as
really?
this
Was this
program?
tough? Yeah. Was this tough?
No, it's fairly easy. I took, um, I think one of the Spark Fund programs, and there's a tutorial on Adafruit's GFX library,
Mm-hmm.
and just kind of pulled out of both of them to make a Arduino program that scanned through it. And this one has the sensor has an I2C interface, and the display has a SPI interface. And so I'm using one of the quick cables to connect up to I2C. And then this is the SPI interface, all the wires you need for that.
Okay.
And
Because that's for the display.
yeah.
Okay.
Anyway, so I thought it was kind of interesting. That's why I got it. I wanted to see if it could be used for that. And I think the other images where, the scene isn't very complicated, I think that gives you good information. And I think if I can show the peaks, let's see if, I think I rotated after that. Yeah. Yeah. So, okay, the longer distance is, okay, from the top, it would be the left side of the sensor, because that side of the sensor is further away. So that's why you get the peaks, at the bottom end of the measurement, or the trough. Well, let's see. Nope, it's a peak. Yeah. Anyway, so if you skewed it the other way, the peak would go to the other side of the group. Each group of 8, because you're not parallel to either wall now.
Mhm.
So that would be a good way to tell, if you're traveling down the center of the thing, whether you're heading for a corner or not.
Mhm.
If you measure the perpendicular
Yeah,
distance.
that would have been a really good, if you ever set this out again, take a shot at the corner and see what you get. That would be an interesting thing to see.
Yeah, you get a peak in the center, basically, of each one, because as it scans across that, excuse me, the peak is going to be in the corner from the device, but so the peak just moves around a little bit, but you're only talking about eight sensors horizontally, or 8 measurements, so it's not going to vary, not unless you're really skewed. It's not going to vary that much. And this represents a distance of 3 meters, I think. So this is down in the centimeter level, maybe not even. But well, actually, no, it's got to be more than that. Several centimeters.
Mhm.
Anyway, so I thought it was kind of interesting. It kind of showing some promise. Like I said, the scan rate isn't that fast. He's got another one where I think he actually pushes it to a megahertz, even though I thought the max for the I2C interface was like 400 kilohertz.
Well, let me ask you this. You're using the ESP32 now pretty exclusively as your microprocessor of choice?
Yeah, that, and for these little proto boards, I'm really liking the Cutie Pie, because it's got one serial interface, one I2C interface. It's got the quick connector. It's got a SPI interface. It's fast. It has lots of memory. So for stuff like this, it doesn't take up much space on a proto board, and it seems to have all that I need for something like this. But yeah, for the other one, I'm using an ESP32, and it's plenty fast enough. It has, again, all the interfaces on it. It's got Wi-Fi, Bluetooth. I found the ESP Now is really handy to show on where is it? Oh, there it is.
By the way, did you get
It's
an
also
upgrade in
video.
your Wi-Fi, or are we just lucky tonight?
I think it's the luck, not unless, all my complaining actually got T-Mobile to stick more towers out here. But yeah, this has an ESP32 in it as well, and I can use ESP Now to basically kind of tell me the operating state of the robot, the calibration of the BNO 055, the latitude and longitude, what function I'm in, what the encoder counts are, even the battery. I got the battery voltage up on here now, so that's kind of nice. Don't have to have a separate display on the robot. I can just look at this thing and it'll tell me what the battery voltage is.
I think that would be a good thing for a lecture, if you could go over your project there on that, because I use a Wixel for debugging, and
Yeah.
in the room it's fine. Out in the backyard, it's marginal, and I really would like to get something that had a little more distance
Range, yeah.
because
Yeah.
it's so nice to be able to get your data and then look at it afterwards, or actually while it's going on.
Yeah.
So anyway,
Well, actually, on the ESP32, you can run MicroPython on it, and you can use a web REPL that is when you're running Python or MicroPython, you have the um, read, execute, print loop, if you will. And on the ESP32, you can do that wirelessly. So that means that now you don't have to actually have a cable over to your unit to program it.
Mhm. Yeah, like I say, this is a post competition. Let's get like to maybe
Yeah.
explore these things because it's. I've been really enjoying I'm using it on my robot right now at Teensy 3.2.
Hmm.
It's not probably the one I would buy. Well, actually, I actually think it's a really nice compromise of the Teensy boards because when they went to 4, they went faster, but they lost their 5.5 volt tolerance. So, and since unless you can just absolutely keep your system at 3.3, which if you're using servos, that means no, you aren't. And if you're using some of these, like the LiDAR, the Bennywake LiDAR, that's got to have 5 volts or it just doesn't work. Now, it's kind of weird because it has 3.3 serial ports, but I guess because of their laser, you're popping that that diode really hard as a laser. It probably needs a higher voltage. Okay, that's just.
I have a servo on mine. It works with the 3.3 volts.
Oh, that's pretty good.
As an output from the ESP32,
Yeah,
it's
I
within.
Well,
run,
I'm not talking about the serial. I'm not talking about the signal. That yes, that will work at 3.23. Well, I
Yeah.
was talking about powering it. You got,
Oh, okay.
if you try to power a servo at 3.3, I think it'll choke. Not a little less
Oh,
90,
yeah.
not a little less G90, but if you're talking about a full standard servo, I
Oh, yeah,
don't think
for
they're going to
sure.
be happy at
Yeah.
3 volts. Yeah.
right.
On
I'm just
mine,
thinking
I'm
the
actually.
control can be 3
It's
volts, but the power you can have 5 volts.
Yeah.
Yeah, right. That's what I'm doing. So.
Yeah.
Yeah, the ESP now is very simple. I mean, basically, you just create a structure with all the data that you want to send, and I timed it with just a port pin, setting it high, doing the transmission, setting it low, and it's it's in the if you like I think probably around 10 microseconds, and the transmission is done, and it's not a huge data structure, so it's not like pages and pages of data or a video image or something like that, but you know it's not going to affect any of your loop timing being that fast. So
No.
And I've even sent it some of the things. Initially I was sending them 20 times a second, and you can kind of see the numbers and things ramping up or climbing or decreasing or whatever, but so the display is fast enough, but it's not like you can pick out a number in that when it's doing that. It's just too fast, so I went back to 1 second.
Mm-hmm.
That seems fine.
Yeah.
So but anyway, that's all I had.
Nicely done.
Okay, I got a question. What does time of flight mean? What does it mean?
You're actually measuring the time like a light pulse takes to get out and come back, reflect off an object.
Oh, okay.
So
Since that's so fast, Mike, what they do, that you have to do special stuff to be able to really measure time of flight. A lot of times they'll do something sneaky, like they'll flash a light from an angle and then they pick it up against the sensor, and depending where it hits the sensor, they know what the number is. But that's can be done a lot slower. With time of flight, I believe most of them just actually use the phase of the angle of the poles to detect the
I think
timing.
you'd have to check. There's some white papers. We looked at this a couple years ago, but ST Micro, the vendor for this part, has some white papers, and they've got some patents that are inside that chip that relate to counting photons somehow. So they send out a burst of photons in a prescribed pattern, and then their so-called SPAD detectors, which are listed in the data sheet. Well, they accumulate the number of photons, and so it can measure distance in really tight quarters. And it's really amazing to me because I worked my first design project in the career was at Texas Instruments, working on military laser rangefinders, which were time of flight for tanks. So we would have a big cavity of CO2 gas or a solid state laser rod, and we would make a pulse of laser light that lasted 100 nanoseconds. I mean, it was really if that long. And that pulse of energy, like the one I remember, it left the cavity at 287 megawatts, but it only lasted for 100 nanoseconds. So you'd send out this really bright burst of light, and it would travel like 10 kilometers, bounce off of a tree or a deer or a tank in the distance, come back to the atmosphere. So you'd broadcast 280 microwatts of light, and then whatever that worked out to, like, it's 33 microseconds for 10 meters of range, basically. Speed of light works out to that. So you'd count the number of 33 microsecond clock ticks and or nanosecond clock ticks, nanosecond, because it was a 33 megahertz crystal. So and then that would tell you how far away it was. So it would 280 megawatts of light would go out, and then the receiver was sensitive enough that it could detect microwatts of optical energy. So anyhow, so it's been really fascinating for me because that was my first thing out of college. I spent 5 or 6 years in that group. And then what happens? Mobile phones come along, right? And it turns out that if you look at how mobile phones are made, like this is an iPhone right up there in the top. One of those little things is a light sensor. Another little thing is a time of flight sensor. So what they're actually doing is that as you put it close to your head, it's measuring how close the phone is to your head by bouncing light off of your ear so that it can turn the volume down so it doesn't blow out your eardrum.
Cool.
And that's why ST Micro has made, I mean, they chug out bazillions of these every year because there's one in every phone, or maybe multiple. They might have some in the back for their rear-facing cameras, right?
Well, they're now using lidars are now being put in the back of the cameras.
Yeah.
They're doing it with the intent that eventually you'll be able to do a lidar scan of stuff.
But think about it from ST Micro's point of view, right? If you think of how many mobile phones there are, and there's maybe 2 of these sensors in every mobile phone on the planet, what a business model. So it's just wonderful for us because now we can go buy those sensors from SparkFun, and Ray can have an 8x8 sensor array
for cheap.
For $25. I mean, that's what gets me, because these military things, okay, we sold to like Texas, or TI sold to, like, say, Turkey or Greece or whatever, and the least expensive rangefinder that we sold was $20,000. Okay, it was mil spec, and it could range to 10 kilometers through smoke and water and atmospheric conditions, but yeah, $20,000 down to 25 from SparkFun.
That's amazing.
Anyhow, that's my rant. That's all I can contribute for the night.
It was a good one.
Well, Ray, thank you. That was a good demo. It'll be fun to see what you
Thanks,
can do
Ray.
with that. And
I've had it for a while. I've just, outdoor robots working, the time suck, it's
we're tired, guys. You're killing me.
didn't have time for anything else.
You're killing me. Okay, so next in queue we had John, and then Michael, then Doug, Todd, and John K. So John G.
Okay, yeah.
John G.
Do a screen share and deployed my last night. I deployed my skull face, my two skull face tracking skull faces for Halloween. So let's see here. This is what I didn't have anybody to help me do videos, so I can't show you kids' reactions because I was handing out candy too. Here we go.
That's awesome. Pretty good.
So one screams and the other grunts. Is that it?
Yeah, he didn't grunt. He was actually just snapping his teeth,
Oh,
trying to bite the viewer. That was it.
Way to go, John. All right. I think that's a gold star. Who would argue with me on
Definitely.
that?
Definitely.
Yeah, it was a big hit with some of the kids. It was the adults that were scared of it. It's like, come up, and the kids, the problem with kids is they're focused on the candy and they're not going to slow down and look. So I have to say, hey, look over here. Go look him in the eye, stuff like that, to get him to. And one 8-year-old kid, I said, get closer. And the skull had screamed at him. He dropped to the ground. But he thought he wasn't crying. He just thought it was funny. But I had adults there that said, come over and look at it. Oh.
Way to go. That's super cool. And by the way, so Todd, John 3D printed those skulls.
Wow, that's impressive. And I was thinking maybe for next year, if you want the kids to really look, that's the only way they get candy. A little hand comes out and drop the candy in the bucket or something.
I didn't design the skull myself. What I did was I went to Thingiverse and found a set of STL files for someone who had modeled a full-sized skull. And it was actually like a 28-piece kit of pieces that you fit together with magnets. You glue magnets to the seams, and so you can assemble a full-size skull. What I did was I went into Prusa Slicer and took the individual pieces on the front of the face and merged them so that I could have just the front of the skull and have the jaw printed out separately. So yeah, all those things were 3D printed.
Wow. Now, do you have your own 3D printer or did you outsource that?
I've got an MK 3S Plus from Prusa.
Okay.
I'm printing right now. I don't know if you can hear it, but I'm printing more stuff. Printing some supports. I've got this security camera that I built. All of that box is 3D. I designed the box myself and 3D printed it. Now I'm going to put it on a swivel, and so that I can tilt it up and down. Because normally I just had it mounted where I can go side to side. I want to be able to swing side to side and pivot. So I'm designing a swivel here so I can do that.
Wow, nice.
So I imagine one of your big questions is, what can I 3D print? Or I don't know if you have anything in mind, but it depends on if you have lots of projects. You'll always find an opportunity to 3D print something.
Right.
yeah, it beats trying to fabricate it out of metal, a whole lot faster, and you can do several iterations and
Cheaper
But it looks
too.
like there's a number of businesses though that you can basically just send out the file to them and they'll print it for you, I guess.
Yep.
But I have no idea what those, the costs are yet, but
Well,
It's cheaper
3D
at the
printers
house.
run the gamut on prices. You can go as low as $200 for something like your high school kid might want to just do things like print figurines or whatever, all the way up to thousands. Like, what's the most expensive on the market 3D printer that you guys have seen?
A house printer out of concrete.
Yes.
Well,
There you go.
that's commercial. I'm talking about,
Yeah.
you know,
And the ones that do laser, they instead of doing PLA, they deposit metal with a welding rod, and then they have one head that deposits it with metal, and then another one that comes in afterwards and grinds it down.
But for
Oh, you
for-
mean for our stuff?
for-
Okay.
but for our stuff, I will recommend a Micro Center to go visit them, because a couple years back you would make the printer, but nowadays it's simpler just to buy, and it's actually cheaper long term wise. So I would suggest go visit Micro Center. You can sort of see the different ranges and types there.
Okay.
Yeah, they actually had one on sale for 100 for a little while. I think they had, I don't know,
And it-
25
it'll-
units, and
And it'll probably happen again.
yeah,
If
As we
you,
get closer to Christmas.
probably
Yeah.
Black Friday or
and
whatever.
here's the thing: if you're starting out and you don't know what you're going to print with it, what you might do is buy a really cheap 3D printer and get some experience with it and see what kind of things you know, what kind of features you're going to want eventually in your expensive printer.
Yeah,
Gotcha.
but
I recommend that.
I think the create, what is it? Creativity,
Reality.
reality.
yeah. Printer, it's got a real good robustness. I mean, it's one of the most simple things.
And you can get them for about 200 to 300 at Micro Center.
Yeah,
There's one right there as a Creality.
yeah,
So
and,
You can get that for
Uh,
$100.
yeah.
It's the one they were selling at Micro Center for $100. And that,
Wow.
Yeah,
I
my
love it.
first 3D printer was an M3D printer. Was basically a little cube, so you can only print something on a bed about maybe 4 inches across,
I wanna
4 or
say
5
4 and
inches
a half,
across.
but
It was
it's
really
still wow.
well. At the time I bought it, it was like $300. Nowadays, something like that would be really cheap, but it was still early in the game.
Yeah.
So I learned a lot from playing with that, and then
So the
eventually I moved up to features that I wanted, like a bigger bed, a heated bed to keep the print from warping. I wanted to run headless, so I didn't have to keep it hooked up to my computer all the time. And of course, I wanted a good quality print too.
Gotcha. You mind if I show you what I was kind of looking at?
Sure.
Okay.
I mean, unless Carl, we have time.
Well, yeah, I mean, we had another.
Or
Well, that's fine.
I'm
Let's
sorry,
let's just go with Todd right now, Carl.
Okay,
Okay.
sure.
Sorry, I didn't hear you.
Everybody's into it, so
Well, we
this
could tie
happens a
back
lot. We
into
just
it at the end. I
find
mean,
a
I have
rabbit hole
something.
and go down and have a good time. So guys, while we're going down this, why don't you check for links on the printers that you're recommending, and put those links in so that we can share them to Todd and whoever else.
At the part to part show, there was an HP printer. I think it cost around $10,000, but this was basically three-dimensional little box. It's got this like a latch that holds the thing together so you can fold it. But that's $10,000, So,
yeah. The neat thing about this was that it was literally printed as one part. That's cool. It's just incredible.
Oh yeah, this thing.
Yeah.
Yeah, can you see
Right.
my screen?
Yes.
Yep.
Yeah, so this is like a maker's muse or whatever muse out of a guy out of Australia. And anyways, I mean, I thought this might be cool for a first project.
Yeah. Like I say, I still think the Microsoft, going to Microsoft's a good example. Getting the create.
The
What
Micro
is it?
Center, the
Yeah, the
Creative-
Ender 3.
Yeah, I mean, it's a works
Ender-
out of the box experience,
and
which most of us, when we started with 3D printing, that was not the case.
Okay.
But it's now, I mean, my daughter bought one, started printing she's a professor at UTD, and she's into modeling. It's part of what she teaches students, and she just went up with it. Now eventually she went and got she got a resin printer, but she started off with one of
And they
those.
sell those there too for about $200. I have a resin printer.
Yeah, but I would not recommend going into a
well,
resin
not
printer.
initially.
Well, no, because the resin printers, there's a lot of post processing. I mean, I actually have a resin printer too, but I'm just saying, it's just.
But for the robot,
for a robot, it's just not where you want to go.
well, the main reason why the resin is for more detail. Effectively, get a 10% increase in quality of detail, because Carl said, like building the house, what you get is layers build up.
Okay.
So by getting 10 times more detail, you don't get the lines basically in there as much. But
Yeah.
you'll see the examples. They probably have a sample or two there, so you can ask the guy. They're
But
pretty
don't go there, Todd. Don't go there. It's not as a beginner. As a beginner, and they're slow. There's a lot of post processing, and if you want, and the resin's not as strong. So if you build in parts, you want to go with one of the, what do they call them? FD. What do they call the type of? It's not a resin printer.
Are you
Basic.
talking ABS?
Huh?
FDM.
About ABS?
FDM. You want to do an FDM printer. So
Yeah,
that's just means, all that means is that you have an extruder that you heat plastic that's in a long.
I provided links in chat on
Yeah.
the two main pieces of my skull project. The first is a Thingiverse link to the 18-piece human skull. And then the second link I put in there is the animatronic eyes that went in the skull. That's a separate project that I found that's 3D printed.
I would say that for a person who's just getting started, if there's something that you want to make, search for it on Thingiverse. Unfortunately, Thingiverse itself gets so much traffic of crap that, just literally crap, that it's hard to find the jewels on that website.
But there are some good ones.
But there are some exceptional things. And if you're, so let's say you want to build gears.
Okay, I'll show
there's
you.
There's a gear, an automatic generator of gears.
Modeler.
That you can do it.
Parametric, right? So you do dimensions, number of teeth and whatnot.
Everything, thicknesses, width. If you want herringbone, you want a double herringbone, whatever you want.
So here's an example of one, okay, where they actually have a robot on top of, so you can see there the basic robot, and then they're putting stuff on top, and this is all 3D printed to give you an idea of what can be done. So that's why, it's
That's amazing.
So and as I said, that's all. It could be fiberglass. They have printers out there now that actually will print tough material, basically. But that's an example of one.
Now any recommendations for like the CAD/modeling type software that you use?
There's lots of them out there, but Doug and I used a thing called Design Spark Mechanical. So you might look into that too.
Yeah. It depends on how big a learning code you want to make. Design Spark Mechanical.
Tinkercad.
Yeah, Tinkercad is simple.
Onshape.
Yeah.
And then if you want to get more elaborate, there's a thing called Fusion. So 360.
Fusion 360.
Spark Mechanical is really a beautiful tool.
Yeah. and there's some that you can pay for that are real expensive, but for free, I like Design Spark Mechanical because I make parts.
Okay.
Okay, and I also I like it because it thinks the way I think, and after you play with it a little bit, you can make it sing and dance. I never wrapped my mind completely around the Fusion 360 interface, but it has got features that are just second to, that it's a commercial product that they just give you a free license as a hobbyist with restrictions.
Okay.
So
Very popular too.
yeah.
360.
So
But isn't it so that, I mean, from my way of understanding, that tools like Design Spark Mechanical, they're just, I mean, they're there for you to come up and model some kind of 3D object, and they're well suited to structural and mechanical robot-y kinds of things like
yeah,
simple brackets and the kinds of things we find on our hobby robots.
right.
Whereas, as I understand, the Fusion 360s and SolidWorks and all those others, the professional ones, of course they do that, but they go beyond that, and they'll have like physics models where they can model
Yes.
joints, and they can model
Yeah, but not on a hobby.
and they can model
Hobby license.
parametric things, and so you can
And that's
do.
why you pay more for the, because yeah, you're right. They can actually do structure analysis
Yeah.
type
Yeah,
things, and they have the bill and code.
That's
There's
what
a
I was
lot of cool
with
things
trying
it.
to
you
say
can
is
do.
that the learning curve. So the benefits of the learning curve are you can do things like, what is the mass of this object and how is it distributed around the volume of the geometry?
Right.
Or
Yes.
like if this arm on my robot rotates from here to here, will it interact and interfere with this bracket that I happen to have modeled in there? So those more advanced tools give you access to other stuff, but they have quite a learning curve. And
And require
unless you
more
do
memory for your computer, et cetera, et cetera.
unless you do something like join the Dallas Makerspace, where you can have access to those as a part of your membership at a nice, reasonable rate, they're going to be expensive for you to get on your own.
Yeah.
Yeah, that's,
Yeah,
that's
by the way, I don't think this has come up. You're going to need two pieces. There's literally 4 pieces of the pie. One is the printer, one is the CAD software. You got those 2.
Yeah.
The third one is the slicer, and then the last one is the filament. And for a beginner, I recommend PLA because it's the easiest filament to use. And I'll be quite honest, I do 95% of my stuff in PLA.
And
At least-
nowadays,
at
it's
least
getting
possible.
hard to get
The
ABS.
only
at
thing about the
Micro Center.
PLA is it will melt in your car in the summer.
Yeah,
Right.
so
Yeah.
He's pretty good.
Especially this last summer.
Yeah.
But
For anything
It'll
outdoors
sag.
that's going to get hot, PETG is the way to go.
I use ABS for everything.
yeah. But
Okay.
but the easiest for a beginner is PLA.
It's Lego uses for their plastic.
Yeah.
So when you're checking out the printer, notice for like the PLA, you don't need a heater bed per se. Now for an ABS,
or
you
a-
will want a heater bed.
Yeah,
Okay,
but
so there
for
are little
ABS, you
differences.
also need an enclosure to really do it right.
That's
So
I mean,
really
that's
I'm
why
not
you
saying
get a
you
little
can't make
different.
them. You can't make a model with it, ABS, without an
Oh,
enclosure.
that's why I was
Here's
saying
what,
as you're looking at the printers over at Micro Center, you'll see the different types. So yeah, definitely I would recommend, don't buy the first one you see. Ask 1 or
Right.
2 questions beforehand. So
Okay.
here's another example of, okay, somebody has it. Okay.
the Fusion 360. You can even import. This is a camera. Somebody provided a model of the camera that I bought. I incorporated it in my box model, and then this is a partial board that I designed for the IR illuminator. I imported that from another program. And then these are the pieces was printing out now. So you can see I've done a lot of work with Fusion 360.
Yes, I get to see that. Because I don't think I could do that.
But I'm sure that it's paid off because John, you do some pretty complex stuff, and I'm sure that it would have been much more difficult if you were trying to use a tool that didn't have all those features that you just showed.
Well, to be fair, a lot of what you just saw, as long as you had nice square objects and maybe cylindrical, I haven't gone into the more complicated stuff like using splines to build a curved, complex curved surface. I've done it like once, all right, but it would take some practice for me to really kind of get it down. But there's lots of for Fusion 360, there's lots of how-to videos available to learn how to do stuff.
That's the beauty of it. But the problem with it is it's because it has more options, it has more layers, so you have to go through the menus. Where you see the Design Spark, Mechanical, or one of those others, they tend to have a push and go technique. So it's more upfront, easier.
Gotcha.
The
So-
clearest example is how to design a motorcycle engine. No, I'm only kidding.
So, yeah.
And then you step up to the jet.
And then turbines and
So,
So
here's
Todd started off by asking or mentioning some of these online services.
so
And
yeah. I was going to say before jump a little bit, I was going to say here's I don't know why I said it's not to avoid infinite window or why. Anyway, I'm trying to show this. I don't know what is complaining to me about, but hopefully you're seeing it.
Yeah, I can see. Little,
Okay, they're the real. This is another thing, like example of a tank tray you can make with the printer. So that's another example of one thing that was off of Thingiverse.
okay.
And you could design this in a CAD program really easily.
But if it's available out there, is the CAD program or the model for that, or downloadable, like
Yes.
open source, or not necessarily?
Yes, it is.
It's downloadable, but it's in
It's in an
There's
STL format.
right. So
Okay.
that means it's harder to
manipulate.
modify, to edit and modify.
It can
You
be
can-
done.
Yes and no.
Yeah.
Design Spark lets you import a STL file and muck with it.
So will FreeCAD. FreeCAD lets you import an STL file. That's
Yeah,
what I've been using.
Yeah, I use I use FreeCAD, and I have a commercial program that I use
Well,
too.
when you import an STL in those two programs, though, the STL files basically are a bunch of real tiny facets,
Right.
right? So it's not the original model is much easier to modify because all you got to do is pull surfaces and whatnot.
And sometimes
if you're-
people actually put the base file out there, if you want to think of it that way, in whatever program they were using
Yeah.
to model in. So it depends. It's
Yeah,
it's
John,
not as
if,
simple
for
as yes,
example,
no answer.
If you take an STL file and turn it back to a step file, you're going to end up like every circle is going to be segmented. So instead of being a circle with a cylinder, it's going to be a segment of rectangular pieces that
Slice.
form a circle.
It's like the difference between source code and a binary compiled.
Yeah.
Mm-hmm.
So you don't want, I mean, you can do that. And that's why, like John mentioned, some people put the source code on Thingiverse, but that is fairly rare. It depends. But sometimes you can email the guy and he might be willing to do it for you, send it to you. So,
Okay.
When 3D printers first came out, it seemed like a lot of like your local library would have a 3D printer for you to use.
yes.
Are they still doing that? I mean, I have
Yes.
my own, so I
Yeah.
Your local makerspace will have them too, a lot of times.
Like Louisville has one, I know, and once they put up at Frisco, they have one.
So
And
that's what I wanted to raise. But Todd, I think you're in South Dallas then.
Yeah.
Yeah, I'm down at Waxahachie.
Yeah.
Okay.
You
So
might
those-
you might check the library. They might
You
have
might.
one.
Yeah.
Might have one that you can use. Otherwise, you won't be able to use it. But what you can do is you can take your file to them, and they'll put it in a queue to be printed.
My
And,
library, their printer was always down and broken, and they
Yeah.
wouldn't let me try to fix it either.
yeah.
Oh God.
Oh, they didn't know who they had on hand then, Todd.
No, they didn't.
That's too bad.
Yeah.
And here's, if you just have STL files to work with, here's something you can do in your slicer. All right. The skull project I was talking about, you can see I
Yeah.
just brought in the individual STL files. And then in the slicer, I fused them together. And then I added these exclusion areas to keep this piece from being printed out. So everything you see in these boxes here and these cylinders here allows me to skip parts of the area here.
Mhm.
Yeah,
So
that's
it
pretty
doesn't print
cool.
those parts.
Yeah.
This is Pusa slicer, right?
Yeah, this is Prusa Slicer.
Yeah,
Oh, that's cool.
yeah, and that's a very good slicer.
I don't know
A
if you're.
little bit harder to use than some of them. Cura is another good one. CURA.
Will
and,
Cura do this?
I've had Cura.
I don't know. I
Uh,
haven't,
it's
I haven't
been a-
used Cura in a long time.
It's been a while, but as I recall, it's not nearly as fancy as Prusa's Slicer.
Right. I don't think so. I think Prusa is pretty cutting edge for hobbyists right now. Unless you buy that one. There's one called Slice It or something that you pay money for. But
Well, there's
Pusa is
Simplify
free.
3D, which is fairly inexpensive and it's pretty good.
Which one is that?
Simplify 3D.
That's the one I was thinking of. Yeah. Okay.
That I,
But-
that's the one I use.
Yeah.
Okay.
But Pusa is probably, if I were a beginner, well, you might as well, jump in with both feet. Go ahead and learn Pusa. I mean, what he was showing you is not what you need to that's not what you need to just make a print. Okay. He was showing you a technique that was pretty advanced. Probably you just import your file, push a few buttons, and out comes another file that's sliced for you.
Actually,
what-
that's not what I was using was not that advanced, and I used like maybe 10 to 20% of the slicer's features.
Yeah, but what I'm trying to say is, as a beginner, you don't even
For a
have to do
beginner, yeah.
that. It's
Okay,
much
yeah.
simpler than that. You just say, here's my model. It pops up on front of you. You push a button and it slices it, and that's it.
You might
Yeah,
have to
you don't
tell
have
it the
to-
material, maybe.
Yeah, you probably have to tell it the material. And there's going to be some machine constants that you'll have to add into it. But if you buy something like can't ever think of that word, what is it?
Creality.
Creality, they're going to have a profile for that already. So it's not a big deal. And then when you get your printer, there'll probably be a little disc with it that has a slicer on it, and that's fine to start with.
So are you feeling overwhelmed yet?
Yeah, well, I figured there was going to be just like anything. There's a lot to it, right?
Surprisingly, once you got up on a little bit up the curve, it seems simpler and simpler. It's not,
So,
You've got YouTube University, so you'll be all right.
well, there's just about anything and everything on that.
But there are a few topics that get pretty much everyone in the club fired up, and this is one of them.
Yeah.
PID loops, 3D printers,
3D printers.
handful of other things.
yeah.
Arduino.
Can I ask one more question?
Speed controller.
So are most of you all building like autonomous kind of robots or like
Yeah,
remote
we
control?
only build autonomous robots. We
Okay.
don't. Yeah.
Well, let's clarify that a little bit. I'm a little off the beaten path.
Me too.
As you can see,
Or,
from
let me
my
ask you
skull
this:
project,
did you start with remote control and then graduate up, or did you just-
Sometimes.
As a matter of fact, after this session, I was going to show you some pictures of my claw machine from last night at my Halloween carnival.
Oh, wow. That's good. Cool. See
Michael and
But when
John
we
have
get
been
through
holding
here, I'm
up
going to
the,
show a few of them.
Michael
Yeah,
and
so
John have been holding
basically-
up the animatronics and Halloween part of the club.
Yeah,
so.
basically anything robotic, you know, but
Anything.
right now, a lot of people are focused on autonomous navigating robots.
Okay. Wow.
So there's just a sampling of what we have.
So
arranged.
I'll drag us a
But-
little
but
bit
if-
back to the robot part in the process.
Yeah,
So
Todd,
let me show
if you think about it, in this group, only one person here, I think, doesn't have a 3D printer. Everybody else on this page that you're looking at has a 3D printer. There's
I
only
don't.
one.
Okay.
Who was that?
Am I one or two? I don't have a 3D printer.
Oh, you don't? Well, I guess that's two. I thought you did.
And then there's
I was going to
Murray.
say David doesn't have a 3D printer.
And then there's Murray,
Oh
who's
yeah,
anti 3D printer.
they'll never have
Yeah,
a
I got
3D
a
printer.
3D printer from way back.
So here's another one that you could 3D print, and this is a basic one. So, okay, so you'll notice, okay, so you'll notice here it's basically a simple base. Now on here, there also the main reason I brought this one up is that it uses a relatively cheap motors that you can get for like about $14 or $12, give or take. So this is a good basic robot if you want to build a basic one.
Okay.
And I think if I run this, if I
Okay.
run this, I think it'll, well, you can see the 3D printer in the background. Speaking of 3D printer. There it goes. So you can see it has the little ping sensor in the front. So I think it has a ping sensor. Yeah. So it can avoid bumping into objects and that. So that gives you another example. So yeah, you could build something like that probably for, assuming you had the printer, you could build it probably for around $40, $50 at most.
Wow. Awesome. Okay.
because like the Adria board you can get for around $12, give or take. And then like the pin sensor would be about $7. The two motors about $10. So yeah, so this is an example of one to sort of get basic start off from.
Hey, Kareem, do you have videos of your excavator?
And then you can go bid. Yes. Well, that would be good. Yeah. If you, yeah.
I don't know if he's online. Kareem, are you
All
there?
right, what was the question?
Oh, you have a good video of your excavator?
You want to see it now?
Yeah, yeah.
Oh, sure. I can pull it up.
Was that always remote controlled or was it ever autonomous?
It's both.
Oh, okay.
So, yeah, there was an autonomous mode where it was doing, it was running around a square, right? And it had a calibration routine where it was just doing a back and forth thing. And then it also had the ability to override it and remote control at any time.
Yeah, because Kareem, I think we lost the last time we had you show this. That video did not come out. So this.
Oh, it wasn't part of the recording. Yeah.
Right. So this would be kind of like the official. So.
Okay. Sorry, I had tuned you guys out for a minute. I've got my robotics team here today, and
Okay.
so I didn't realize that y'all were talking about that kind of stuff. But I can go to YouTube and let me see if I can pull it up real quick.
And there's lots of other things you can print. I'm always finding reasons to 3D print stuff. This is a power box for this remote security camera I want. And then let's see if I can show it here. The solar, this 10-watt solar panel I've got, I designed some 3D printed parts here to put it on mast. This is PVC pipe. And then I'm going to hang it on my back fence to start with. So I've got 3D printed a couple of hooks to hang it on the fence.
Wow, that's awesome.
Inside.
So it saved you hours from just wandering the halls of Home Depot trying to figure out how to, when you
On the
don't have a
inside,
3D printer.
I needed a couple of pieces to hold the battery in here.
Oh,
I
wow.
placed the mount a power switch. That's 3D printed and designed and printed. And then a little place to put the regulator. So I've got a place to mount the regulator. I've got a box to fit that into. So all sorts of little 3D printed parts on this thing.
Wow, that's awesome.
Sam doesn't have to be a robot.
So while we're waiting, I can go ahead and show my pictures here. There's a lot of 3D printing on this. I'm gonna go ahead and present this, I guess. That'll be all right.
Sure.
While we're waiting on Kareem. Let's see. Oh, there he is. What was that?
Amber
Probably an
Alert.
Amber
Oh, he's
Alert or
coming, all right.
Silver Alert.
Oh, is that me? Okay,
Amber Alert. Everybody's going to start beeping.
Probably.
here it goes. Y'all see that?
Yeah.
Y'all don't
Yeah.
see anything?
It's just a picture.
Okay, I'm just gonna show pictures. All right, that's my wife. Y'all see her?
Yeah.
Okay, that's after the sun started going down. See that's a my 3D claw machine at the carnival, and man, it was real popular. There had people standing in line. So there's tons of 3D parts on that. All the mechanics are all 3D printed. There's another picture of the kids, and of course all the electronics are up in that tote up there. But the frame is made out of PVC pipe, but the corner blocks are 3D printed, and all the mechanical parts are. There's now look how bright those lights shine. That's pretty cool. And then we're down here, down in the little corner there, and that's all I wanted to show. We had a blast.
That is cool.
I tell you what, those kids just, I mean, they were standing in line for that, and it really I really got a kick out of that. It made me feel good. So anyway, all of those parts are 3D printed, and I'm going to make another one. I'm in the process of making another one like this. These are all 3D printed. I'll show you this somewhere. This is going to be this is just a prototype arm, a robot arm I'm building. In there, of course, there's the Arduino and some buttons, and this is just all for testing. But all those parts are 3D printed. I got it on a bearing, on a Lazy Susan, on some bearings, truss bearings. So anyway, there you go. That's all I got.
I
I
bet
can
people
show
named
you the-
Susan are getting tired of hearing that, huh?
What's that?
I bet people named Susan are getting tired of hearing that.
No,
It's a turntable.
it's a turntable. What else did I get? Where's that at?
So should I go ahead and show
Yeah, go ahead.
something?
Let's
All
go for it.
You see the video?
Holy cow.
Yep.
All right, so this is a play video
The
that the
team
kids put
consists of
together.
up to 2 driver operators.
I'm gonna sort of skip
In this
ahead
game,
of it.
Your robot is the protector of all good things. Ducky is an evil mastermind who has just come off a killing spree. Ducky is planning to overthrow the government. Ducky is a naughty boy who plans to set off fireworks on July 4th unsupervised within city limits during a drought. You must keep him secure. The play area consists of a 40 by 40 foot dirt field. At the start of the game, the robot must fit in a 12-foot cube but may expand to any size thereafter. The robot may not weigh more than 4 tons. The autonomous period starts with Ducky captured in an open 8-foot by 8-foot square
So this
prison
is
marked by
actually
cones on
under
the
driver
corners.
control
Your
at the
robot must
moment, not
patrol
really
outside the
autonomous.
square, completing 1 transit of the perimeter. Your robot must not cross the lines connecting the cones or a major penalty will result from each crossing. Prior to the start of the match, teams may place their robot on the field at any position outside of the prison. Targeting the duck throughout the transit results in an extra 25 points. 20 style points will be awarded for scary behaviors while in transit that would intimidate Ducky into docile acceptance of confinement. During the break between the
So you'll
off-time and
notice
teleop
nobody
periods,
was in the
Ducky
cab. It
escapes.
was
During the
completely,
teleoperated period, drivers will
remote
pick up their
controlled at that
controllers
point.
and will hunt Ducky. Minor injury of Ducky, for example, scratching or light bruising, will be awarded with 5 points each. Death of Ducky will be awarded with 20 points, however, bonus points will be awarded for style deaths. 90 penalty points will be given if you and your robot are outsmarted by Ducky like this, or like.
All right, it's getting sillier and sillier at this point. But I wanted to show. Was there anything else in here that we should see?
So what was the main controller for that?
So I wonder if it. I'm not sure if it's going to show up in this other one, but let me
An
try.
Arduino.
No, it's called a Rev Control Hub. So there's a company called Rev Robotics here in Dallas that is basically creating. They've created an entire control scheme and robot kit that is targeted at high school kids competing in First Tech Challenge across the nation. In fact, across the globe. So there's probably 100,000 kids that are competing in this challenge.
Wow. What language? What do you program in for that?
We are using Java.
Oh wow. Okay.
Yeah. So here's another video. So this is it doing its so this is an autonomous calibration routine. It's just doing. We're sped it up 5 times. It's just doing it back and forth, and it's using RTK GPS to get a very accurate reading on its location. So it's basically at the 2 centimeter range, or around 2 centimeters of accuracy. And then this is the robot going autonomously around a square. I think those cones are about 8 to 10 feet apart, something like that. I think it's actually following a 16-foot square that I just laid out on Google Earth, and then told it to sort of follow that. And you'll see that the arm itself, the bucket and everything, is still operable while it's doing its navigation routine. And the accuracy at the end of 10 cycles around that, well, it was off by about 4 inches.
Wow.
And yeah,
that's impressive.
yeah. So there's we never actually got around to doing the full reveal video, unfortunately. So there was lots more details to share, but that's what we have available right now.
No, that's awesome. That's impressive. Thank you.
Sure.
Nicely done. So Kareem is in the south area of Dallas as well. Todd, by the way. So you have some company there.
Okay.
We're just north of Duncanville, like right on the border.
And then the rest of us, well, we have one person online from Colorado. Colorado at the moment. And then the rest of us are scattered around, I guess, mid to North Dallas, I guess.
Sometimes
Yep, Colorado.
Mm-hmm. Where in Colorado?
Aurora, Colorado, just outside Denver.
Yeah, okay. I lived in Denver for about 3 years.
Okay.
Cool. All right. Well, thank you, Kareem and Michael and John. So unless there are other topics on those, then I think next in queue was Doug P. And then we had Todd and it's in Connecticut, right? So I think, Doug, you're next.
Okay.
Sorry about that.
Okay. I want to share the screen and just show a little progress. Okay, and like I say, I can't see it now because I'm sharing. But, let's see.
Doug, I don't think you have enough icons on your screen there.
Yeah. So this is it's actually working. It has two modes. It has GPS and it has the camera. And this one, that's the camera. So that was a run where I just pointed it, it saw the camera, and it ran to it. And yeah, it should have an icon over here.
So the cone. So this is
Now this one, it started off in GPS, and you can see it's heading towards it. Now that looks like a hit, but look where, because this is where I found out that a single ultrasonic sensor looking forward wouldn't do it, because if you look at the ultrasonic sensor, which is sitting, it's this right in this area, right here. It's looking at this fence, so it doesn't really know it's close to this. It just hit the cone and stopped because probably the bumper. So I'm going to go to a 3 sensor set angled at 30 degrees to try to overcome this problem. And here it's going, and now you see it's turned. It's probably going to find something. Yeah, here it goes again. Let's see, what was I going to show with this one? Well, okay, so that one should have been okay. And here's running. Here you see it's under, okay, now I should have seen the cone. Okay, well, that one worked. There was something I wanted to show. Okay, so here it's not seeing the cone yet. Then I guess it's probably got the cone now. There, the only reason it's touching the cone. See this, it doesn't know that it's touched the cone at this point. You can see that the bumper's not pushed. So it's sitting here. That would have been the end of the run for this run. So
Is it just stalled there?
yeah, I just stalled there because I've cut the speed back quite a bit. And this heavy St. Augustine grass really makes the robot so light, it's bouncing around. And so what I'll see is see the cone, see the cone, see the cone, see the cone, don't see the cone. And I have to be careful, hopefully it'll see the cone again, but when it didn't see the cone, it starts to drift. So, and a lot of times it doesn't see the cone because the robot's literally bouncing as it's going, it's coming, riding over the grass. And I just wanted to show this to Todd, I believe it is. 3D
Yes.
printed, 3D printed, 3D printed, 3D printed, 3D printed, 3D printed. You see, so that just bits and bobs, everything it's very handy over here, buttonhole, just the holes, 3D printed. It's a lot of 3D printing in this.
Okay.
Yeah. So
Doug, when you get too close, does it sort of lose recognition capability on the cone?
okay.
Because
Well,
now it's no longer got a shape to it.
okay. I've tried to address that, Kareem, by taking a lot of pictures up close. All right. So I've added pictures to the model, but the real answer to this is there should be 3 modes: GPS, camera, distance sensor.
Yeah.
And I got to change. Right now, it's only got 2. When this was shown, it only had 2 modes: GPS and camera. So, uh, that's where I want to go and see how that. So, what I've been working on is okay, what does it do after it hits the cone? It has to back up, switch waypoints and head to the next cone. So I've been working on that routine. I did try it ballistically at first, and that just made if you lose the camera, it just made it a lot longer before it found the camera. So that's not a way to do it. So I'm now making all of those routines non-blocking. It's this one.
Doug, does the camera just say, I see a cone, yes or no, or does it give you?
It gives me a left or right.
Does it give you coordinates within the frame?
Yes. Okay.
And
See there? Did you see that? Now it's in GPS control, and it went over and hit the fence. So, this is a case where right here, for some reason, it didn't recognize the cone. And so now the GPS took over and it just went on its way. So that needs a lot more robustness. So where am I going this week? I'm going to play 2-cone ping pong. Otherwise, goes to a cone, backs away, drives to the next cone, but it's never under GPS control. It's either camera or distance. So I got to use that to work out all these bugs. And hopefully
It looked like in that last video, it looked like it was slewing to the right relatively fast, and maybe the cone just swept by its field of view faster than it could register it.
It's possible. Yes, John, it lost the camera lost it. Either it swept out of the way, or it didn't recognize it as a cone. Because like Kareem said, if you're up close, it's a little different. So anyway, there's where I am right now. Like I say, I'm close to ping-ponging it, and that's what I'm trying to do this week is get it to ping-pong between 2 cones. So 10 cones about 15 to 20 feet apart, and I'll set it next to 1 cone, and it'll drive to the other cone, hit it, hopefully, and then back away and turn, and then head towards the other cone, do this thing back and forth, back and forth. So
it also looked like in those videos that there was an awful lot, there was a pretty big swing in the correction from left to right. If you can find a way to keep the cones centered instead of making those radical corrections, it might be on target by the time you get there.
Well, some of that, yeah, John, I know what you're saying. And actually, I have played with the PID because it's really easy. You only have a swing of ideally 90 degrees, but it's probably less than 90. It's probably about 80 degrees. So you're taking what you see on the camera or what the heading that you got from the GPS, which is 180 to minus 180, and you're scaling it and putting it into your 40 by 40 or 45 by 45 window. If you don't have the PID controller adjusted right, it'll drive into saturation, and you'll stay in saturation until but it'll be too long for you. You'll have missed something. So I am playing with that a little bit. I think I've got it when it's in the camera relatively okay, but I might still be saturating in the GPS because it's different. So.
You'll have to incorporate, this as your your cone for close-up stuff,
Well, I actually
Your
almost did that. You know, it turns out it never quite gets that bad, Ray.
Oh,
Never,
really?
really not. You never, because even when you're touching, the cone slopes enough and the
Oh,
camera's mounted high enough that you have this kind of coney look.
yeah.
It just, so
The
like I
cone
say,
in
I'm
your
just,
face look.
yeah.
Doug, the reason I was asking about whether or not you got location coordinates is,
Oh, you mean X and Y?
yes.
No, I'm not doing any odometry.
No, I'm saying, does the camera itself tell you where within the frame the cone is? Does it
Yes,
give you an
well,
X?
it gives you a centroid of the cone location.
Okay. So if you had a servo mount, a 2-axis servo mount that the camera was mounted on, those uh, those signals could drive the camera to stay centered on the cone.
Yeah, but not
And
this
then
year.
once you have the camera centered on the cone, then the robot's body can be driven by the offsets to the
Yes,
servos. that drive
servo.
the camera.
Yes, I agree. That's really a good idea. In fact, I'm going to write that down, David.
Can I demonstrate that?
Sure.
I have to take over here.
Okay.
So, Doug, we need you to get that done the next 11 days.
Like I say, ping pong first, and then the last week I plan to do tuning. But I almost had the ping pong today, but I didn't quite make it.
Can you guys see a video?
Yep.
So, okay, so that's exactly what's happening here, Doug. And I'm ping-ponging between two cones, one of which is hidden over here behind this tree.
Mm-hmm.
And what you see here is that, again, it's just doing IMU odometry, right? No GPS at this point.
Mm-hmm.
And Todd, none of this robot is 3D printed. See, it is possible. Okay, so about right here, the camera starts scanning left and right. I don't know if you can see that.
Yeah.
It's scanning left and right looking for the cone, and right there it saw it. And so it locks the camera on the cone, and then the robot drives to try and center the camera, basically.
Mm-hmm.
And the other one being hidden at the other end. I think I've described before that as the camera pans down as it approaches the cone, that controls the velocity of the robot. So it automatically slows down, looking for the bumper press. And then if you look carefully, you can see that the sonar array lowers and points straight forward. Normally it points, okay, here it didn't find a cone where it thought it would be. So it goes into this search mode, and there it locked onto it right there. And if you, as I say, the sonar points down because if it's pointed up at all, it just bounces off the cone.
Mm-hmm.
So I actually have to point it down, and you're right. It's real hard as you approach. Basically, I ignore the outer two sonar and I just concentrate on the center two to tell me if there really is something there, because the camera can be confused by things. So there, the sonar went down and is sitting level. And if you watch, after the bumper touches, the sonar kicks back up. And it doesn't kick up very much, but it's enough. So that's all.
Wow.
What actually that actually looks like it would be easier than what would at first appear to be a simpler solution, because like I say, it's much easier to lock, I think, lock a servo on the cone while this thing's bouncing around than it would be to lock, because with an Ackerman, I know you didn't have an Ackerman, but on mine, I think, I don't know, I think it was John who mentioned, it seems like you got a lot of overcorrection, and that there is some to that. So when you see it get a good camera lock, it can go straight to the cone, but but it's going to the cone and it bounces up a little bit. You might lose the cone, in one of your, and this one is running 150 milliseconds between pictures. And so you lose it for 150, 150-second thing. And then the guy sits there and says, oh, go back to GPS control, do this, So there's another option where, I've got written down here is where if I lose the camera, it keeps going in its previous direction. But it depends. If it's tilted, you could end up going off into the woods. So anyway, I'm gonna have to think about this because
basically the way that one is working is that, okay, the thing is when it's in what you're calling GPS mode, when it's just trying to get to the next waypoint, in that mode, the camera scans back and forth. And basically what that does is gives me a wider field of view, right?
Yeah.
So if the cone's way off, and then if while doing that, it sees the cone and locks onto it, then it puts the robot in a mode where the camera drives the robot. So the camera is going to try to stay locked. It's just going to try to keep the cone centered in the image. And that's what's driving the servos. And then the robot itself at that point is reading basically the servo positions and using that to steer itself. And if you do that sort of automatically, the camera will center up. And once the camera is center up, it gets locked in place. It doesn't move anymore. And then you just drive straight toward the center of the image. So there's actually 3 of those states.
Yeah, like I say, I think that because just moving the camera is a lot less mass than moving the whole robot.
And also you have the uppy downy axis.
Yeah.
So as the robot bounces up and down, it can correct for that.
Yeah. Yeah.
You need a gimbal.
So do you got a full pan and tilt on that?
Yeah.
That's definitely going to be a struggle for 11 days. I think I could get a pan, but I don't know if I could handle tilt.
It's not much harder.
Yeah.
I'll tell you what, I've had fun playing with it because, okay, if you're panning back and forth like this and you're driving along on a level surface, that makes sense. And of course, if the robot body tips up, well, the camera will tip down, so you're still scanning the same area, and vice versa. But what happens if you're driving and the robot's, on a slope or something like that? So you're now not scanning horizontal with the horizon anymore. But I've got an IMU and I know that, so I actually twist the scan to match the tilt of the robot body, so that it does scan the horizon even when it's sitting at a crooked angle. I don't know if it actually makes any difference in terms of finding cones, but it was fun to do.
Yeah. Well, that's a next year thing. I definitely guarantee that. But I could see putting it wouldn't be too hard to put a pan on it.
Well, let me grab the robot. Hang on.
I bet you get a lot more. I would say that you get most of the pan gives you probably 85% of what you need. And then the tilt is kind of like gravy. I mean,
the world is not flat, as you know. This is real heavy. It's about 25 pounds. So I don't know if I can hold it here, but let's see if I can get it in a position where you can see the. Okay, there's this mast here, right? And the camera's mounted there on a shaft. It's actually a piece of a fiberglass arrow shaft. And then next to it is the tilt rod. And basically how that works is that there's, oh shoot. I can't hold it.
Can you pull it down, Dave, and let me see where the actual camera is? Okay,
Okay, there's the actual camera.
So it looks like you have it in a U.
And so this drives it up and down.
Yeah.
That servo. And that servo is sitting on top of this servo.
And so it's on, the U is attached to a rod that's going down to the servo.
Yeah. There's a ball bearing right here in this little support. And then I don't know if you can see this or not, but basically it's just one servo mounted on top of another. Uh,
Don't hurt yourself.
that is hard to see.
Okay.
I'll take a picture.
Yeah. Okay. Yeah, it's an elegant solution, but unfortunately not 11 days away.
It worked great at home.
Yeah. But so right now I'm only using the horizontal component of the measurements. So I just know it's left or right. That's all I'm doing right now.
Just give me an X.
But yeah, but they part of it is if mine weighed 25 pounds, I think it would help it. You know what I'm saying? I think mine is so bouncy a little bit because it's too light. But I can't. My suspension can't really handle much more weight because the original suspension was just set there for to have a little plastic shell body of some sort of weird car. So right now the superstructure weighs a heck of a lot more than it was designed for. So even though I've modified the suspension somewhat, I don't think it's enough to.
Have you replaced the shocks and the springs?
I replaced the shocks and springs. I went to a different ones.
Yeah.
I could probably use a little stiffer springs in the rear, but at this point I'm not going there. So yeah. But I tell you what, the next one I build sure isn't going to be Ackerman. It's going to be differential. Might not be 6 wheels, but it's going to be differential because
Expound on that, Doug.
it's just easier to. Otherwise, you see, if mine could stop and say, "Okay, I've lost the cone, stop," and then just turn in place until it found the cone again, that would be easy. But with Ackerman, I can start doing a gentle curve, but I could be completely out and have to go completely around in a circle and catch it on the next time around. Or I can do what I've been attempting to do is I can tilt the steering all the way to one direction and back up a bit and then bring it forward again. The problem with that is, that's real terrain dependent. Otherwise, if you're in a real thick grass in that particular location, you don't turn very much. Well, that's okay because you can just do it again, But if you get too much, you go turn and you're 90 degrees away from the curve, and you got to spin around again. It's not hopeless, guys, but it is. It's a good thing I'm bald already. So
I will say in your defense that even human drivers, when they pull into a dead end alley and have to do that jacking around to get out, even we have a hard time.
Yeah.
Especially without a backup camera.
Yeah. Well, no, you can do it without a backup camera. You just hit a lot more things. It's really frustrating when I see a hand raised. What is it, Ed? Ed?
Ed, you're muted, I think.
He might have thought he was clapping.
Oh.
It's a one-hand clap.
Yeah, sorry about that.
Yeah.
No, I was actually looking for the text message. I was gonna ask Mike whether he completed his claw hand that he was attempting to do for this year. His picture showed the claw box, but he was actually gonna make a modified hand.
I haven't made the claw for that arm yet, but that claw machine. It's actually right behind me right here. You see it?
Yes.
Is actually just it's like it's got a gantry and stuff, just like a 3D printer, and it's got an X and Y, like a claw machine you'd see at At Walmart, like a claw machine you see in an arcade or Walmart, it's just like that. But my next one, I haven't done the claw yet, no, for the arm. But I'll be showing that off pretty soon. So that arm one that I'm building is going to have a whole lot. It's going to be so much easier to transport than this one. So, yeah. But thanks for asking that. I haven't done that yet, but I'll definitely show you when I get it done. When I get, the prototype part of it. So.
Sorry to interrupt you, Doug.
No, that's fine. I was pretty much ended anyway. I mean, like I said, right now, I'm pretty confident that the Oak D light can do what I want it to do. It doesn't need to be an Oak D light. You could have been using an Oak D. I mean, I'm not using the depth information at all right now. That's something that I plan to look at probably for the indoor cameras, indoor contest, because probably about that time that I figure it out. I plan to be using region. Otherwise, right now I get a box. I get a box that goes around the cone, okay, and says this is where the cone is. And I get X and Y and how wide it is and how high, what its height is and what the centroid is. But obviously, if I have all that information, I can make it a region of interest and then just look at the depth. What's the average depth in the region of interest? And then use that information. But I haven't got there. It doesn't seem to cause the camera cycles to go. I think the information is gathered whether you use it or not. Do you know what I'm saying? So it's just up to you to decide to use it. Right now, I'm deciding not to use it.
To kind of half answer Ed's question, I got the prototype right here. Of course, it's 3D printed. I don't know if he's still here or not, but
Todd's here.
Todd's still here. So Todd, this is 3D printed. All this.
Okay.
And see all that. I actually got some melted inserts in there that are very interesting.
Yeah.
Threaded inserts. You get your soldering iron and you just push it down into it.
Oh, really? And it just kind of melts in?
It kind of melts it in. You gotta be real careful because it'll get all messed up if you get too crazy with it. So,
okay. Oh, that's nice.
And then of course this you see how I've got these legs on here that match up, and I bolt these two together like this. Of course, the claw's in the middle of that.
Okay.
I actually stole this claw. It's been through FreeCAD because it originally was off of the club robot. If y'all remember that?
Oh yeah.
So, but it used to be two pieces where you could bolt them together. Well, I used FreeCAD to fuse them. I installed I imported the STL files and edited it after that. So you can do that. It's with a lot of these CAD programs. So.
Wow. Okay.
And Michael, if I remember right, you spent a fair bit of time doing machine shop work, right?
Yeah, I'm actually a machinist by trade.
So now, if there was anybody on this call who could talk about 3D printing versus machining, I would think you're the man.
Oh man, it's like Ray was saying. Ray owns a milling machine. It's a lot of fun now, because machining's a lot of work. It's a lot of work, especially when you do it. I was trained as a conventional machinist, so I didn't get into CNC stuff till later on in the years. And so, yeah, 3D printing is so much fun, so much easier.
I think David Anderson once, a long time ago, mentioned to it. when you machine a part, the more work you put into it, the more valuable the part becomes, and the more resistant you are to changing it, because you don't want to have to start all over again. With the 3D print, if it didn't
You
come
don't
out,
like it, you pitch
you
it.
just
You're right.
Make another one. Didn't mean to interrupt you, Doug. But
that's exactly it.
I have spent days working on extruder dies for the wire industry. Tandy wire, as a matter of fact, back to Tandy days. Spent days on making an extruder die and then trashing it. And it just, you talk about a sinking feeling of doing some die work and then you just trash the die.
Wow.
You know, pretty depressing. But 3D printing, you trash it, you just throw it and do another one. So there you go.
Only thing you have is the time that it takes to print, but you can be doing other things while it prints. So
Absolutely.
that's the beauty of it.
Oh, that's cool. Yeah, I know that feeling when the first internship I did way back when was on the ground launch cruise missile program, and you know, it was pretty cool. Worked hard on it, and then, you know, about a year later, followed up with the guys, see how they were doing, and they're like, "Well, they scrapped the whole program." Yeah. I'm like, "Well, what did they do with all that equipment?" "Oh, they pretty much just, you know, trashed it."
It's out back sitting in the grass.
That's because we got it on a surplus site in the hobby club. That's how it worked.
Yeah.
Thank you, Todd.
The amount, talking about machining, the amount of aluminum that went into those things, it's just.
And talking about the time to 3D print stuff, the skull face, each of those skull faces takes like 18 hours to print. And I printed several of them because, you know, to get them to fit, I never get them to fit just right the first time. So that's a lot of waiting.
Yeah.
So here's an example
metal, right?
of another
near
3D
impossible.
print one. So let me click that. So here's a nice cute one. You can see the claws 3D printed. The whole thing's 3D printed.
Wow, even the tread?
Yep, even the tread. See, there's the body. There's the reel. There's the tread. And it's all printed in one thing, but it's a small robot. So this is where bed size comes into play. A pin. Yeah. I think that's the head. So yeah, that gives you an example of, yeah, you can literally 3D print everything.
Wow. That's amazing.
So yeah, there's that. And then there's other site besides Thingiverse. So let me show you this other site, because there's two sites I would recommend to look at. And so the other one is Instructables. So here's one where they use, 3D printed the parts to build a cube, or and they use Raspberry and a Pi camera. And this one actually is pretty good documentation, and they use Python. So here's the different parts. And then somewhere down here, there should be, you can see all the parts there. And yeah, and then here's all the different STL files.
Wow.
So yeah, they can get pretty elaborate. But yeah, this is actually a pretty good one. So you can, I don't know. Yeah, okay, so you can sort of see, I think those show it in action.
It actually solves the Rubik's Cube, huh?
Now, used in a Raspberry and a Pi camera.
It's amazing how many Rubik's Cube solving robots you can find plans for if you really want to build one.
Yeah, and Doug he did have one of these, or a variation of this. It actually had two like claw hands that would come in. I think this one's more gravity fed.
Wow.
So yeah, this is not exactly a robot, but it sort of is. But the key thing is though is the instructables is another good spot to look at. They have, you can search them, and they'll have lots of different things.
Oh, all right. Now let's not have robot chauvinism here, where unless it's autonomous and navigated, it's not a robot. Huh?
Oh yes. Why is it a robot? Definition of a robot? Yes.
I would definitely call that a robot. But, yeah, and I agree, John. We need to keep all the different types of robots active because they sure learn a lot when you watch these other projects.
Yeah, earlier this year I did made a small milling machine. I'll show you. Share. And this is milling out bearing holders, basically. Oop, how do I get it to play? There we go. It's not playing. There we go. So it's milling out a circle basically, and these two little holes here and here actually hold the bearing in. So that's in a piece of aluminum.
And so,
And
Greg,
you'd have to
you
call
designed
this a robot because it's.
You designed the table underneath the move?
It's an XY table, basically on a drill press. That's the
Okay.
XY table.
Yep.
There's a stepper motor here, and one
Okay.
off. Where is it? I don't think it shows it.
What software are you using to run that?
There was boy, I think
So are you
primarily
using
it's
Gerbil?
Gerbil.
Are you using Gerbil?
Yeah, it was Gerbil, but it was for a milling machine.
I've messed with Gerbil with we made a plasma cutter where I used to work before I retired. A CNC plasma cutter, and we use Gerbil for that. So that's
I think this one.
All right, progress to date for the little milling machine. I have added a 20 to 1 gear head to the Z axis. I didn't have enough resolution on the Z. That, just like before where the stepper was connected to a sprocket, it's now connected to a sprocket and drives the Z axis up and down, via this rod that's used to be have the quill lever in it to pull it up and down. I've got all the electronics mounted on a wooden board in the back of the mill. So these are the three axis drives for X, Y, and Z. That's a 12-volt power supply, and that's a Mega with a Ramps 1.4 board on it. And the kind of the nice feature of the 1.4 is it provides you with a display.
Yeah, this shows what it is.
And you can plug in
see
an
it.
SD card here inside.
Pretty cool.
Programs from it. So, like,
Yeah, there you go.
example, do this. So say I want to go into jog mode. I want to move an axis, and I want to move X, and I'll put in 10 millimeters. And if I move the knob now, it moves X. That was 10 millimeters in the negative direction. It's 10 millimeters in the positive direction. So that's pretty nice. You can get back to the main menu.
So, you know, it's similar to what you'd use for a 3D printer, actually, but kind of set up for a mill.
That's pretty cool.
The card and run it directly. So this setup can run independent of like a universal G code sender and with a PC or laptop connected to it. So that to me is a nice feature to have stuff run independent and not have to have a laptop just sending G codes to a.
There's a 3D printed case.
Anyway, that is my update.
Nice. I like that. Gives me some ideas.
Yeah. I had the XY table for a long time, and the motors. I actually was using it to make wooden bowls, to mill out a bowl with a wood router, and then yanked it off that and set it on the drill press. And, my wife's dad died a couple years ago, and he was a machinist, and I tried to sell some of the drill presses. Nobody wanted to give me anything for them. I mean, drill presses that would have cost $400 and $500. It's like you couldn't get $50 for. So I brought them all home.
Oh, wow.
So
I got one of them little bitty ones in the background. You can see it back there.
Yep.
The Harbor Freight ones. But I'm thinking about getting one of them $500 lathes that you get on Amazon, just to do some, make some little bushings with it. Thinking about getting one of them.
Yeah, he had a 10-inch South Bend lathe. It's flat belt driven. It's got this belt that's about 1.5 inches leather, and I need to get another one. I don't know where I'm going to get it from.
Ray, those are the bee's knees. That's what all the retired machinists I know have, that 9-inch South Bend. And
Oh, really?
It's got a motor back there on a lever, and you push that lever and tighten up the leather belt. That goes back to the days when the leather belt actually went up to the spinning
drive shaft.
Yeah, up overhead, and all of them went down to the end where they were powered by the water wheel.
Yeah.
Yeah.
Or
that was before my time, though.
But I know from personal experience that that's a much coveted lathe. And it's the right size too.
Yeah, you can do. I think the bore is like 1.5 inches, which is it's big enough for most of the stuff that I do. So, and the price was right. So.
Okay, cool. So I think we've pretty much run through the list, unless Todd, if we are there any more 3D printing questions which remain or have surfaced as a result of this?
No, I think you gave me enough to sleep on for today, that's for sure. But I appreciate all the information. This has been an awesome session.
Just remember, there's no harm in going to the library and having someone else print for you if you can get away with it.
And then we can use the CNC router as the nest setup. Yes. And one or two of us have that too.
So I've got a completely unrelated topic. I wanted to ask, has anybody else used these NRF24L01 radio transceivers? No?
Well, actually, I might have it.
I've got one hooked up to I was about to launch off into another project. I've got two of these RF transceiver modules with the low noise amplifier on them, and I've had them sitting around forever. But I want to hook it up to my camera and send images remotely over a radio link.
Mm-hmm.
And so I found a C library posted on GitHub, and has a Python wrapper on it. That's kind of like what I'll experiment with and see if I can get that going. But I guess that's not the kind of thing y'all do Wi-Fi around here, huh?
Well, I've
You
played
have
with other
two-
cameras, other radios, but not that one.
Yeah, I
I've
don't think I
always
have
wanted to. I wanted to because they're so those are the ones that you see a lot of them. But what I'd like to do, John, if you would put your link for where your module with the preamp and everything is, and the antenna, maybe we can look at it and see.
I'll have to dig because I've had it sitting on the shelf for quite a while. I think I got them on Amazon, but those are everywhere and they're really cheap.
Yeah.
I'm sure I could find it on Amazon. I'll look for it.
It's
Yeah.
like a 2.5
might post
megahertz or
GitHub.
gigahertz transmitter.
Well, here I could probably find it right away. I'll look real quick.
Some of them are like a tenth of a watt.
Oh yeah, I found it right away. Here, I'll post a link.
Oh, thanks. Appreciate it.
Supposedly, the ones I have supposedly can go up to 1 kilometer.
Probably not a tenth of a watt then.
Really long link, but there it is.
Okay. Oh, that's great.
Matter of fact, let me check the box. Where's the ball? Here it is. Oh. Now, the one I got quite some time ago, I don't know if you can find it on Amazon, is Maker Focus. So I might not have got that on Amazon, but you can find lots of variants of them around.
I think I have played with this one. This is, I think, what they used to use with Audipilot.
Oh wait, there's a second link I found. There's the Maker Focus version right there. the Maker Focus version.
Not these little ones.
Also, it comes with a power adapter with a regulator on it.
Yeah.
That's the one I have right there.
Well, these don't. The ones that are with the second link there, they just have a little tiny antenna. I know they're not going a kilometer.
And I've messed with plenty of these before, but I wrote code for them from the ground up, but using a PIC controller.
Yeah.
So I've written the C code to control them on a PIC controller, but rather than try to rewrite another program to run it off a Raspberry Pi, I'd rather just download somebody's library because that was a lot of effort to get it working.
Yeah.
You've seen the ESP32 cams, right? They're using Wi-Fi to transmit a video image.
Yeah, I figure you guys always go for Wi-Fi or Bluetooth.
A little different than those.
But with this thing, you can get some range.
Yeah, I looked at the Amazon page, but it didn't say how much power it put out. So I think the ones that get that kind of range, though, they're somewhere between a tenth of a watt and a watt for output power, which is quite a bit. So
Yeah, and I don't see anything on the box that tells you that.
Yeah.
Mr. David, you are muted. It's too early for the Nutcracker, but I could imagine.
Like my skull face laughing.
Get some teeth
Well,
chattering.
just looking at the Amazon page, it is a little tricky, the wording. It says maker focus, blah, 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 RF transceiver module 2.4G 1100M. Now, does that mean 2.4 gigahertz, 1100 meters, or is that the model number?
Yes, that's exactly what it means. 2.4 gigahertz, 1100 meters range.
Yeah, that's line of sight, you know.
Yeah, I wonder how that works in a forest.
Mm.
And one interesting thing about those is you set them up where you can have one master talking to 6 transceivers, 6 receivers.
Cool.
Yeah, I don't think I'd even attempt to be able to send a video image on something like that. It would be probably
Well,
not
I did
trivial.
mention that there's there's a GitHub library just for basic communication, like you want to send messages. And then I found another GitHub link where some guy has a technique for basically cobbling together packets of an image and sending them with checksums, so that if you drop one, because if you don't want any errors in your image file when you transmit a large file. So he has actually his checksums and a protocol for resending corrupted or lost packets.
Mm-hmm.
So I'll start with the basics first and then work my way up.
Just what we need, another protocol.
Yeah.
We checksums and retransmissions.
Oh boy. All right. Very cool. So I think we're almost pretty much out of exhausted queue. I think, or John K, did you get your stuff earlier on, or is there still
Yeah,
some?
I sort of rove it all throughout. So yeah.
Okay.
Tap
Well,
out for
that-
now.
That leaves us with more open mic time. So let's see. Any other open mic topics for du jour? Quiet night. All right.
How was your Halloween traffic this year?
Yeah.
It was better than last year, but still kind of. I think COVID kind of ruined Halloween.
It may have hurt. It's hard to tell on my street because I think like there was that rain. A lot of us bought houses with kids, and now the kids have moved off, so there's only a few young couples. So the next street over was bopping, but our street was pretty quiet.
Oh no, it's like I'm always seeing. I'm on the first house driving into our neighborhood, so I'm always seeing cars driving in from other neighborhoods and dropping people off. That's where we always get our Halloween traffic.
There you go.
People come from outside the neighborhood.
Well,
That used to happen in Capel every year. It's like, hey, where'd you come from? You're not a neighborhood kid.
Like I said, I had my claw machine at that church carnival, and it's pretty busy, real busy, as a matter of fact. So it was doing pretty good.
Cool. I think trick or treat parties and trick or trunk, they call it.
Trunk or treat.
Trunk or treat, whatever.
Yeah.
I think those have become more popular in the COVID era, and that's what's drawing a lot of kids away.
That's what we had was trunk or treat, but some of the people had, like me, that had games coming out of their trunk, and little, throw the bean bag kind of thing, and so they got little games. And we are moving we used to have a lot of carnival stuff, and we're moving away from that into the trunk or treat kind of stuff. So
I think the best Halloween I ever had, it was when I worked at DSC Communications Corporation. My boss, Tom Marisuck, knocked out one of his front teeth somehow. And it was just before Halloween. And you know how those like Halloween stores kind of pop up before Halloween and then disappear? There was one really close to DSC. You know, I drove past it on the way into work and stopped there and got this little tin of black wax and sliced it all up and gave it to everybody who wanted to participate. And we all blacked out the same tooth that Tom was missing. And we're all walking around, you know, at this.
Just like Tom.
Just like Tom, you know, so, you know.
Well,
And,
next year, I want to try taking those Halloween skulls that I made and mounting them on a full-size plastic posable skeleton. I've got a couple of those.
Or you could get really weird and mount them on your spider.
Well, my spider's was in the middle of redesign, and I kind of put it on hold for a while because I didn't like how it was working.
But I mean, that would be creepy with the spider with one of those skulls on it. That would be
real creepy.
Well, you know, the other thing to do is besides putting the skull on top of a skeleton, full skeleton, is I want to have the arms. The arms are opposable arms. I want to have like the arm also follow the tracking that the eyes do. So when somebody comes up, you know, the arm points at them and follows them as well. So that's all. That's one of my goals.
Okay, I have one more kind of club question that comes to mind, and that is for the 12th of November. Can we just get a rough count? Who all is planning to go to Robo Columbus in person on the 12th of November?
I plan on going, but I'm not going to compete.
Let's just count attendees right now because there's food involved, right? So there's
Not
1,
sure yet.
2, 3,
1/2,
4, 5. Okay, you guys get hands. You got to go up and stay up. This up and down stuff, I just can't. Okay, so we got 1, 2, 3, 4, 5, 6, 7.5. Okay, I got 7.5. And then anybody.
Hey, Carl, where is that located again?
North of McKinney, right? Or
Yeah, it's in Farmersville.
Farmersville or Princeton? I can't remember which one.
He's on the south end. He's not in Farmersville. He's south of Farmersville, but he has a Farmersville address.
Okay.
It's one of those, like, you know, 4 miles, 5 miles outside the city limits sort of thing. Of course, the city limits, it may have moved, for all we know, last year or two.
Are we talking about Steve's place?
Yeah.
Yes.
Okay.
And so we'll
Should we
let's
touch
ask that
that?
question again next week, Doug, and see if we get about to try and estimate it. And then the other thing is for remote. I don't know if Pat or Ted or anyone is going to want to remote in this year, but we should learn that out so we can set it up.
It's getting complicated.
I know. Okay, guys. I don't know of anything else. Is there anything else anyone wants to bring up tonight? All right. So we had some gold stars. We have hand waves. We'll see y'all Tuesday online.
Okay, wait a minute. Gold stars. Who got the gold star?
It'll be in the notes.
Okay. All
I
right.
think you got it, Doug.
I got one, I think, but there's other people who.
You got one, and someone else
It
did. We didn't talk about.
It was John.
Yeah, John.
Did I get one?
Yeah, you got one for your show.
Prize rolled.
And one we didn't talk about was Ray with his blinky lights, but
I'll take all the gold stars you want to give me.
He might get a black star.
might get a black star.
Okay.
All righty.
Good enough.
Yeah.
Okay, guys. Anything else?
Nope.
Nope.
No first. Okay.
Okay.
Have a good night.
Good night.
Night,
Nice
everybody.
meeting you.
See y'all next week. Stop recording.